Hi, I'm Calculus, and this is my good friend Derivative. You will never escape them. They will haunt you in your dreams. So, you're interested in taking calculus, huh? Well, here's some things that you need to know. Calculus AB is sort of like a big old tree. It's got a big trunk, aka one main topic, with a whole bunch of other things that branch off said main topic. For us, that topic is derivatives. By technical definition, a derivative is an expression representing the rate of change of a function with respect to an independent variable. A derivative can be used to find the slope at a specific point on a graph, to find the limit of a function, and to find equations from other things, like acceleration from velocity. This can be useful in professions like physics, engineering, statistics, economics, all those math things. Now, you might be wondering, how do you find a derivative? How does that work? Why am I the way that I am? Well, I can't answer that last one, but I can tell you how to find a derivative. There are so many derivative rules, so we'll just cover the basics. One of the easier equations to derive is one like this. Now, when you have a little chunk that is x to a number, you take that number, put it in front of your x, and separately subtract 1 from your number and stick it in the spot where the original exponent was. 2x is the derivative of x squared, 3x squared is the derivative of x cubed, 1 is the derivative of x, etc., etc. Also, as a note, if there's already a number in front of your x, say like 3x, you simply do your derivative stuff and then multiply your answer by that number. Sometimes your teacher wants to assault your eyes by giving you a trig function. However, there's no need to drop out. You just have to remember which ones go with which. Sine becomes cosine, tangent becomes secant squared, and secant becomes secant tangent. And I can already hear your cries of distress, but what about cosine? What about well, it's easy. For each co-function, simply take the corresponding function, switch it from regular to co, or vice versa, and slap a negative on that boy. Cosine becomes negative sine, cotangent becomes negative cosecant squared, and cosecant becomes negative cosecant cotangent. Now, sometimes you're going to see a big squiggly line boy, or a sneaky boy, depending on who you ask. The squiggly line is called an integral slash antiderivative, and it's basically the inverse operation of a derivative, hence why it is called an antiderivative. Your squiggly mans usually comes in one of two forms, naked or with numbers. When your integral is naked, your answer when you solve it will typically be an equation with plus c. Do not forget the plus c. However, when your boy has numbers on the top and bottom, after you find your antiderivative, you have to integrate from your top number to your bottom number. Basically, you plug in your top piece to your antiderivative and subtract the bottom number plugged in. Easy! But there's rules! Honestly, the antiderivative rules aren't that hard once you know the derivative rules, because they're the inverse operation. Got us 3x squared? Add 1 to that exponent and divide by your new number. Negative sine of x? Now it's cosine. It's not that hard, silly. Now, this video doesn't even come close to scratching the surface of calculus. However, I hope I've helped to convey a few key concepts/points of the class. Bye!